purpose of this video is twofold. First, emphasizing the needs for correct and regular maintenance on the evaporative coolers, and second, to illustrate the possibilities for repairing one that looks to be a lost cause or corroded beyond repair. Here's a picture of the left side of the cooler. You can see that due to the water leaking internally, it's splashed all over the place, corroded a majority of the frame and metal pieces, and severely stained the entire side, or the entire inside. Here's a little closer view of that left-hand side, showing the spider, which is connected to the fan or blower, and the bearing and axle. The white matter around the circular portion is the calcification that's building up over time. The red parts of it are the rust against the axle, and the next slide we'll see a close-up of that bearing and how it's seized. Here's a picture of the right side spider with pulley assembly. The fan belt is connected from that pulley up to the motor, which turns the blower and gives you the forced air. You can see that the calcium is built up rather severely, and there's a large amount of corrosion. The next slide will show you a close-up, and you'll see up in the left-hand corner the calcium buildup on the pulley, and of course the surface rust on the blower housing. Here's a rear view of the blower housing assembly. You can see the same calcification, staining, and severe rust towards the bottom. Here's a front view. There's quite a bit going on here. The bottom section, or the bottom rectangular section, is where the cookie sheet or damper slides in for winter. It shuts off the heat, or keeps the heat from escaping up through the cooler. And above that is the front view where the water float assembly is, and the corrosion here is just very near non-repairable, but I was able to repair it. A good portion of the corrosion that is seen below or inside that rectangular area was due to the fact that there was no drain. Every time the water was drained or overflow, it splashed down inside here and just basically stayed wet, and that allowed a lot of corrosion to happen. Here's a close-up of that water float valve assembly, and you see the severe corrosion on that blower, the front portion of the blower housing. The customer complained that there was a water leak inside the home coming down through the ceiling in one of the bedrooms. It is very likely that this was leaking from the blower assembly down through the ductwork due to the gutters inside here, or where the water is pumped into, being dissolved. Those gutters have since been replaced. Here's a picture of the front, where the water line has been stuffed through the hole where the water float valve assembly is usually attached. I may opt to recommend to the customer that that float valve be relocated to where that hole is. The surface corrosion that you're looking at is easily sanded and painted, and has already been accomplished. The picture you're now looking at is a tie that ties the top part of the cooler to the bottom part of the cooler. You can think of it as a tornado tie that's used in the construction of a home. During high winds, this tie provides stability and locks that cooler in place. There are other screws holding it together, but this particular tie and the one on the other corner will need to be replaced, or it will compromise the integrity of the cooler. Here's that opposite corner tie. You can see that it is severely corroded and will also need to be replaced. Here is a representation of one of the 4 panels that hold the pads that take in the water and provide the evaporative cooling effect. You can see that due to years of leaking and neglect, there's severe calcification and rust. These panels were saved, but they were right at the brink of just dissolving and having to be replaced. Here's a close-up of the corrosion treatment on a panel. You'll see the left-hand side has been prepared for paint, or actually prepared for primer and then paint, and the right-hand side is waiting for the same. Here again is another panel showing the severe calcification. This calcium was built up so bad that a machine had to be used to knock it off prior to beginning the corrosion treatment. Here's a picture of that same panel with the pneumatic slag remover, and you can see that it does do quite a good job of getting that calcification off, although it is very labor intensive and can be expensive. It is less expensive than buying a new panel. Here is a picture of all four of those same panels. The calcification or slag has all been removed. They've all been primed and painted, and they're ready to install. Here's a rear view of that same blower housing assembly after corrosion control treatments and priming. Here is a rear, somewhat aerial view of the entire cooler put back into service. The entire cooler was painted to have it match all of the panels. Here is a right side view of the cooler that has been put back into service. You will notice that on the bottom there is a water filter that's been connected to the water supply line. This will minimize, not eliminate, but will minimize the calcification that's been happening over the years. And here is a rear left side view of that same cooler that's been placed back into service after the corrosion control treatments. Here again is that same cooler that's been put back into service, this being a front view. You can see that the drain line has yet to be installed. It's fabricated, but just laying there. I hope you found this video to be helpful and informative. And please remember, if you have need of our service, just give us a call. Phone number is on the screen.